Hi guys, as you see, I am not in class today. I had a little bit of a family emergency and I will be back next week. But until then, we will be doing a little bit of virtual learning. So if you look at the new chapter that we're doing, we're definitely going to skip chapter 3 because it's a little bit of a repeat of what we've already done. So we're going to start with chapter 4, which is everybody's exciting stuff, exponential and logarithmic equations. I understand that they're a little bit scary for everybody. Everybody don't panic on me. We're going to take it piece by piece. So the first thing that we're going to do today is learn how to graph the exponential function. So what does it mean when I say an exponential function? Well, the exponential function that we're going to talk about is any function, like so, that carries an exponent as an x. There are many different ways of writing exponential functions. So we can get a whole number or we can get a fraction number. And the most important thing for you guys to realize is that any other variation of this is just a transformation like we studied last chapter. So for example, if you see me write something like this where it's negative 1/4 to the x, you should be able to recognize that this is a parent function and this is a transformation. So what does that mean? That means that I can now graph any function that I see that's exponential using a simple x and y grid. So let's start with the first one that I gave you guys. Y equals 3 to the x. And I start with my regular graph. And as always, we're going to do an XY chart. Start with -3 all the way down to 3. So I start. What's 3 to the -3? Well, 3 times 3 is 9. So 3 times 3 is 9, and then 9 times 3 is 27. And now, as we saw before, we're going to the -3rd. So if I come and I do my 3 to the -3, when you do it in your calculator, we remember that the negative sign means 1 over. So it's really 3 over 3. So my value is really 1 over 27. So I come back to my chart and I put in 1 over 27, which using the calculator gives you 0.04 approximately. Then I come and I do 3 to the -2. Once again, the negative flips me down, giving me 1 over 9, which we all know is approximately 0.11. So I come back and I put it in. Now, I know you guys all have your calculators in front of you, and it's okay if you just want to completely graph on the calculator. You do not have to do piece by piece like I'm doing right now. It is your choice as long as you understand what it is that we're doing. 3 to the 0. Well, we know that 3 to the anything, or anything to the 0, sorry, is always 1. So 3 to the 0 gives me 1. 3 to the 1 gives me 3. 3 squared gives me 9. And 3 to the 3rd gives me 27. And now I graph. At -3, I have 0.04, so I'm extremely close to 0. At -2, I have 0.1, 0.3, 1. At 1, I have 3. At 2, I have 9. Which means I'm already shooting all the way up here. And this gives me a graph that looks like this. And for those of you who did it on your calculator, it should be a very similar graph. What does this mean? This means that as I come down here on the negative side, I'm going to get almost to 0 but never hit 0. So now x equals 0 becomes an asymptote. And this way, I'm going to keep going all the way up, and it's just going to go to infinity. Good. Let's try another one. Y equals 1/4 x. And we're going to do the same exact thing that we did before. From -3 all the way down to 3. The important thing to remember here is that we can always do this in our calculator. I can just plug in 1/4 -3, which would give me 64. 1/4 to the -2, which would give me 16. 1/4 to -1, which would give me 4. 1/4 to 0 always gives me 1. 1/4 to the 1 is 1/4. 1/4 to the 2 is 1/16. And 1/4 to the 3, guys, what's 4 times 4 times 4? We get 64. So 1/64. As you guys move through this, make sure that you double check on your calculator. Remember to always, once you're on the calculator, you're going to go to y equals. You're going to put in the equation 1/4 in parentheses, the caret, and then x. And then you're going to hit graph. And you want your two graphs should look very similar. So I go -364, which is going to be ridiculously up high. -216. -1/4. 0, 1, and it gets an even very similar equation. Now, obviously, this is not to scale. I did not do it, but you get the point. The reason that I want to show you this is because the two graphs that you're going to see have to do with the base. Is the base a whole number or is the base a fraction? These are the two we looked at. And as we saw, when it was a fraction, we came this way. And when it was a whole number, we went that way. These are our two base functions. These are the parent functions that we talked about before we start flipping and doing and moving. Okay, now that we've gone over how to graph, go ahead and go to the worksheet. You're going to look at the worksheet that is called Exponential Functions Graphing. I want you to, it's on Edline. Your substitute teacher should also give it to you guys. I want you to go ahead and practice for the rest of class how to graph exponential functions. I'll see you guys soon. Have a good day.